Welcome to this second video on exponents and power. In today's class, we shall be discussing the laws of exponents and some representative problems based on the laws of exponents. I'm sure after watching this video, your ideas about the laws of exponents will be clear to you and there won't be any doubt left in your mind. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. Effort has been made to explore the mathematical concepts through the basic ideas in mathematics. In this video, we are going to study the laws of exponents and how to use them. First, we will see multiplying powered numbers with the same base. 2 cubed multiplied by 2 squared. It will be, for 2 cubed, we will write 2 multiplied by 2 multiplied by 2 multiplied by. For 2 square, we will write 2 multiplied by 2. Now here 2 has been multiplied 5 times, so it will be 2 raised to 5, and this 5 is formed by addition of this 3 and this 2. So which means that whenever you are multiplying two powered numbers with the same base, in this case the base is 2 each, then all we have to do is to write the same base and raise it to the power which you get by adding the powers, in this case 3 and 2. Next, let us see minus 3 squared multiplied by minus 3 raised to 5. In this powered numbers, we observe that the base of the powered numbers is same, that is minus 3. So it will be, for minus 3 square we will write minus 3 multiplied by minus 3 multiplied by minus 3 raised to 5. For minus 3 raised to 5 we will write minus 3 multiplied by minus 3 multiplied by minus 3 multiplied by minus 3 multiplied by minus 3 5 times, which will be multiplication of minus 3 7 times. 1 2 3 4 5 6 7, so it will be minus 3 raised to 7, and we see that this 7 is obtained by adding power of the first number, which is 2, and power of the second number, which is 5. So whenever you are multiplying powered numbers with the same base, this is important, all you have to do is to write the same base and raise it to the power of sum of powers of individual numbers. Now we are in position to write our first law, which is a raised to m into a raised to n equals a raised to m plus n. To understand this law, we first have confirmed that the base of the two numbers is same. Then we have to raise the same base to the sum of the powers of individual numbers. To understand this law properly, let us solve a few examples. In the first example, let us confirm that the base is same, which is 2. So we will raise the same base 2 to the sum of powers of the individual numbers, that is 5 plus 3. That gives us 2 raised to 8. In the second example, the base is same, which is p, so its power will be the sum of 3 and 2. 3 plus 2, so that will be p raised to 5. In the third example, there is multiplication and the base of the two numbers is same. So we first have to write the base, then we have to raise this base to the sum of powers of the individual numbers. So that will be 4 raised to 5. In the next example, there is multiplication and the base is same, which is a. So we have to raise this base a to the sum of the individual powers, that is 3 plus 2 plus 7. So that gives us a to the power 12. In the next example, there is multiplication and the base is same. So we will raise this base 5 to the sum of the individual powers, that is 3 plus 7 plus 12, that will be 5 raised to 22. And finally, there is multiplication between the two numbers and the base is same, which is minus 4. So we have to raise this minus 4 to the sum of the individual powers, that is 100 plus 20, which will be minus 4 raised to 120. So this is how we can apply the first law of indices: a raised to m into a raised to n equals a raised to m plus n. It is important to note that we cannot apply this law if the basis of the two numbers is not the same. For example, we cannot apply this law for 2 cube multiplied by 3 squared because here the basis of the two numbers are not same, or we cannot apply this law to a raised to 5 multiplied by b cube because here the basis of the two numbers is not the same. After multiplication, now we will consider dividing powered numbers with the same base. For example, consider 3 raised to 7 divided by 3 raised to 4. This we can write as, in the numerator we write 3 multiplied by 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 3 7 times, and in the denominator we will write 3 multiplied by 3 multiplied by 3 multiplied by 3 4 times. Now multiplication of these 4 threes cancels with multiplication of these 4 threes, and we are left with 3 multiplied by 3 multiplied by 3, which will be 3 cube. Now this 3 is nothing but subtraction of this 7 and this 4, that is 7 minus 4. Therefore the same 3 raised to 7 divided by 3 raised to 4 can be written as the same base 3 raised to subtracting 7 minus 4, which will be 3 cubed. Take another example: 5 raised to 6 upon 5 squared. This is, in the numerator it will be 5 multiplied by 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 5 6 times, and in the denominator 5 multiplied by 5 2 times. Now here this 5 and this 5 cancel with each other, and we are left with 5 multiplied by 5 multiplied by 5 multiplied by 5, which is 5 raised to 4, and this exponent 4 is obtained by subtracting this 6 minus 2. Therefore, we can directly write 5 raised to 6 divided by 5 squared equals 5 raised to 6 minus 2, which will be 5 raised to 4. So, in dividing powered numbers with the same base, all we have to do is to write the same base and raise it to the subtraction of powers of individual numbers. Now we got our second law, which is a raised to m upon a raised to n equals a raised to m minus n. Its meaning is, whenever there is a division sign between the two powered numbers and when their bases are same, then the same base is raised to subtraction of the individual powers. To understand this second law better, let us solve some examples. There is division sign between the two numbers. The base is same, so we have to raise this same base 11 to the subtraction of the powers of the individual numbers, that is 6 minus 2. So that will be 11 raised to 4. There is division sign between the two numbers and the base is same, so we have to raise the same base 2 to the subtraction of the powers of the individual numbers, that is 9 minus this 3, so that will be 2 raised to 6. There is division between the two numbers and the base is same, so we have to raise this same base 10 by subtracting the individual powers 8 minus this 4. So that will be 10 raised to 4. There is division sign between the two numbers and the base is same. So we have to raise the same base 9 to the subtraction of the individual powers 11 minus this 7. So that will be 9 raised to 4. There is division sign between the two numbers and the bases are same. So we have to raise the same base 20 to the subtraction of the individual powers 15 minus this 13. So that will be 20 squared. There is division sign between the two numbers and the base is same, so we have to raise this same base to the power of subtraction of 13 minus this 10, which are their individual powers, so it will be 7 cubed. It is important to note that if the bases of the given numbers are not same, then this law cannot be applied. For example, we cannot apply this law to 2 cubed divided by 3 squared, because here the bases 2 and 3 are different. Similarly, we cannot apply this law to x raised to 7 divided by y raised to 5, because the bases x and y are not the same. We have to simplify the expressions and write the answer in the exponent form. 3 squared multiplied by 3 raised to 4 multiplied by 3 raised to 8. Here the base is same, which is 3, so we will raise this base 3 to the sum of the exponents of the individual numbers, so that will be 2 plus 4 plus 8, so that will be 3 raised to 14. There is a division sign and the base is same, so we will raise the base 6 to the subtraction of 15 and 10, so that gives us 6 raised to 5. There is a multiplication sign between the numbers and the base is same, so we will raise this same base to the addition of the indices 3 and 2, so it will be a raised to 5. There is a multiplication sign between the numbers and the base is same. So we have to raise the same base 7 to the addition of the powers x and 2. So it will be 7 raised to x plus 2. There is division sign between the numbers and the base is same. So we will raise the same base to the subtraction of this t minus this 2. So it will be 8 raised to t minus 2. For the first two numbers, the base is same. So we write the same base, and since there is multiplication between them, we will raise this same base to the addition of individual powers 3 and this 2 multiplied by, we have to write this 5 raised to 5 separately. So it will be further 2 raised to 5 multiplied by 5 raised to 5. We cannot apply rule of multiplication here because the bases 2 and 5 are not the same. So we have to keep it as it is. Now we will see how to calculate when the power of a number is raised to another power. For example, how to calculate 2 cubed squared. As usual, first we will write it as 2 cubed multiplied by 2 cubed 2 times because it is square here. Now since the base is same and there is multiplication sign between the two numbers, we will raise the same base to the addition of the powers 3 and 3. So that gives us 2 raised to 6. But can you observe this 6 is obtained by multiplying this 3 by this 2. So it will be 3 multiplied by 2 equals this 6. So we can write this 2 cubed squared directly as 2 raised to 3 multiplied by 2. So that will be 2 raised to 6. We will take another example, 2 squared raised to 5, which means we have to write 2 squared 5 times and multiply them. By applying the first law, we can write this: since the base is same and there is multiplication between the numbers, we raise this same base to the sum of individual powers. So that will be 2 plus 2 plus 2 plus 2 plus 2 5 times. So that gives us 2 raised to 10. But do you observe that we can obtain this 10 by multiplication of this 2 and 5. So this 10 is 2 multiplied by 5. So which means we can write this 2 squared raised to 5 as 2 raised to this 2 multiplied by this 5. So that gives us 2 raised to 10. So similarly, we can now directly write 3 squared raised to 4 as 3 raised to 2 multiplied by 4. So that will be 3 raised to 8, or 7 squared raised to 10 directly as 7 raised to 2 multiplied by 10. So that will be 7 raised to 20. Now we got the third law of exponent. A raised to m raised to n equals a raised to m multiplied by n. Here, when one power m is raised to another power n, then we have to multiply these two powers and write a raised to m multiplied by n. 6 square raised to 4 will be 6 raised to 2 multiplied by 4. That will be 6 raised to 8. 2 square raised to 100 will be 2 raised to 2 multiplied by 100. That will be 2 raised to 200. 7 raised to 50 squared will be 7 raised to 50 multiplied by 2. That will be 7 raised to 100. 5 cubed raised to 7 will be 5 raised to 3 multiplied by 7, which will be 5 raised to 21. How to multiply powered numbers with the same exponent. 2 cubed multiplied by 3 cubed. We write 2 cubed as 2 multiplied by 2 multiplied by 2. And we write 3 cubed as 3 multiplied by 3 multiplied by 3. Here, since the powers are same, we get 3 groups of this 2 multiplied by this 3 multiplied by this 2 multiplied by this 3 multiplied by this 2 multiplied by this 3. Now 2 multiplied by 3 is 6 multiplied by 6 multiplied by 6. That gives us 6 cube. Now here this 6 is obtained by multiplication of the base of the first number, which is 2, multiplied by base of the second number, which is 3. So therefore this 2 cube multiplied by 3 cube we can directly write as multiplication of the basis, which is 2 multiplied by 3, and we have to raise it to the same power, which is 3. So that will be 2 threes are 6 cubed. Now consider 3 squared multiplied by a squared. Here the powers of the two numbers is same, which is 2. We write 3 squared as 3 multiplied by 3 multiplied by, and a squared as a multiplied by a. Since the power is same, we get two groups of this 3 multiplied by this a multiplied by this 3 multiplied by this a. So that will be 3a multiplied by 3a, which will be 3a, which is the base raised to 2. Now here this 3a can be obtained by multiplying the bases, which is 3 and a. Therefore we can write 3 squared multiplied by a squared directly as 3a squared. Now we write our fourth law, which is a raised to m multiplied by b raised to m equals a into b raised to m plus n. 4 cube multiplied by 2 cube. Here we have the same exponents, which is 3. So we first multiply bases 4 and 2 and raise this product to 3, which will be 8 cubed. 2 raised to 5 multiplied by b raised to 5. Here the exponents are same. So first we will multiply the bases 2 and b and raise this product to 5, which will be 2b raised to 5. A squared multiplied by t squared. Here the exponents are the same. So first we will multiply the different bases a and t and raise this product to 2. That gives us a t squared. 5 raised to 6 multiplied by minus 2 raised to 6. Here the exponent is the same, whereas the bases are different. So first we will multiply the different bases. 5 multiplied by minus 2, and we will raise this product to the power 6. That gives us minus 10 raised to 6. Minus 2 raised to 4 multiplied by minus 3 raised to 4. Here the exponent is the same, whereas the bases are different. So we will take the product of minus 2 and minus 3 and then raise this product to 4. So that will give us minus minus plus 3 twos are 6. So it will be 6 raised to 4. In the reverse operation, now we have to express 2 multiplied by 3 raised to 5 in the exponential form, which we can express by applying this fourth law in the reverse manner. That means now we will work from right hand to left hand. So what we do here is we give this power 5 separately to each of the bases. That is, we write 2 raised to 5 multiplied by 3 raised to 5. We have to express 2a raised to 4 in the exponential form. So we will raise this 2 to this power 4 multiplied by this a to the same power 4. We have to write minus 4m cubed in the exponential form. So it will be minus 4 cubed multiplied by m cubed. We will first multiply minus 4m 3 times. Then we will separate out minus 4 and multiply it 3 times. And then we separate out m and multiply it 3 times. Now this multiplication of minus 4 3 times gives us minus 4 cube, and this multiplication of m 3 times gives us m cube. So which is nothing but what we have written here. Same thing we can do here. We will multiply 2a multiplied by 2a multiplied by 2a multiplied by 2a 4 times. Then we write it by separating out 2 multiplied by 2 multiplied by 2 multiplied by 2 4 times. Then writing multiplication of a 4 times. So that will give us, for this multiplication of 2 4 times, we will write this 2 raised to 4, and for this multiplication of a 4 times we can write a raised to 4. In the same way we can solve this sum also, 2 multiplied by 3 raised to 5, and get this same answer. Now we will discuss dividing powered numbers with the same exponent. We have 2 raised to 4 upon 3 raised to 4. These are the two powered numbers which we are dividing, and they have same exponent 4. So in the numerator we will multiply 2 4 times, and in the denominator we will multiply 3 4 times, which we can write as 2 upon 3 multiplied by 2 upon 3 multiplied by 2 upon 3 multiplied by 2 upon 3 4 times. So that will be 2 upon 3 raised to 4, according to the first law of indices. Here, a cube upon b cube, where the index of a and b is the same. We will write this as, in the numerator we will multiply a multiplied by a multiplied by a 3 times, and in the denominator we will multiply b 3 times. This we can write as a upon b multiplied by a upon b multiplied by a upon b 3 times, which we can write as a upon b cubed. 4 raised to 5 divided by 3 raised to 5. Here the exponents of the two numbers is the same. So this we write as 4 multiplied by 4 multiplied by 4 multiplied by 4 multiplied by 4 5 times upon 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3 5 times. So this we can write as 4 upon 3 multiplied by 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 4 upon 3 5 times, which finally we can write as 4 upon 3 raised to 5. Minus 2 cubed divided by b cubed, we can write this as, in the numerator, minus 2 multiplied by minus 2 multiplied by minus 2 3 times, and in the denominator b multiplied by b multiplied by b 3 times. So this we can further write as minus 2 upon b multiplied by minus 2 upon b multiplied by minus 2 upon b 3 times, which finally can be written as minus 2 upon b cubed. From this we get our fifth law, which is a raised to m upon b raised to m equals a upon b raised to m. P raised to 4 divided by q raised to 4. Here there is a division sign and the powers of the numbers are the same. So we write it as p raised to 4 upon q raised to 4. So according to this law we can write it as p upon q raised to the same power, which is 4. 5 raised to 6 upon minus 2 raised to 6. Here the powers of the two numbers is the same. So we write it as 5 raised to 6 upon minus 2 raised to 6, and after that we can write it as minus 5 upon 2 whole raised to the same power 6. Working in the reverse manner, we can expand 3 upon 5 raised to 4 as, we can write a upon b raised to m as a raised to m upon b raised to m. Therefore, we can write this as 3 raised to 4 and 5 raised to 4, whose expansion form will be multiplication of 3 4 times in the numerator and multiplication of 5 4 times in the denominator. So that gives us the expansion. If we want to expand minus 4 upon 7 raised to 5, here also we can work in the reverse order according to this law 5 and write it as minus 4 raised to 5 upon 7 raised to 5 equals minus 4 multiplied by minus 4 5 times in the numerator and 7 multiplied by 7 5 times in the denominator. So this becomes the expanded form of minus 4 upon 7 raised to 5. Friends, if you like this video, please click the like button, share this video with your classmates. Don't forget to subscribe this channel to get more videos of this type. Give your comments to make these videos better. You can suggest topics on which you want me to make videos. See you in the next video. Until then, keep watching Number Collage. Thank you. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. Effort has been made to explore the mathematical concepts through the basic ideas in mathematics.